everyone. So my name is Yasmin and today I'm excited to introduce our project titled Gravimetric Analysis in Determining the Mineral Content of Drinking Water. To grasp this topic fully, let's break it down into two parts. The first part is understanding the mineral content in drinking water, and the second part is about the gravimetric analysis itself. Firstly, understanding the mineral content in drinking water is crucial for our health and compliance with international standards, such as those set by the World Health Organization (WHO). Various minerals are present in our drinking water, including calcium, magnesium, iron, and zinc, each offering distinct health benefits. Calcium supports bone development, magnesium aids muscle and nerve function, iron is vital for oxygen transportation, and zinc facilitates wound healing. However, imbalances, either excess or deficiency, can lead to health issues. For instance, too much calcium may contribute to kidney stones, while insufficient magnesium can cause muscle cramp and cardiovascular problems. Now, let's delve into gravimetric analysis. It's an analytical technique used to quantify the amount of a substance by measuring its mass. In our context, gravimetric analysis involves isolating the analyte as a solid precipitate, which is then filtered, dried, and weighed.
Here is the theory. Gravimetric analysis determines the amount of an analyte ion by measuring the mass of a solid. Gravimetric analysis works on the idea that the mass of an ion in a pure compound can be calculated and then used to calculate the mass percentage of the same ion in a known quantity of an impure compound. It is a simple and straightforward technique that can be used for a wide range of analytes. It also requires accurate weighing and careful control of experimental conditions to ensure accurate results. It can be time-consuming, especially for samples with low concentration of the desired component. Next is methodology. This is the overview of the procedure. First, precipitate calcium as calcium oxalate. Second, filter, wash and ignite the calcium oxalate to convert it into calcium oxide. Third, weigh the calcium oxide, and last but not least, calculate the calcium content using the molar masses. Now, we will go through step by step to determine mineral in drinking water. First, collect sample collection and preparation. Collect a representative sample of the drinking water to be analyzed. Ensure that the sample is free from contaminants that might interfere with the analysis. Filter the water sample if necessary to remove any suspended particles. Second, precipitation. Add a reagent to the water sample that will react with the mineral ions to form an insoluble precipitate. Add ammonium oxalate to form calcium oxalate precipitate. Next, digestion. Allow precipitate to form completely and then digest it to ensure that it is pure and crystalline. This can be done by heating the mixture gently for a period of time. Fourth, filtration. Filter the precipitate using a suitable filtration method, such as using filter paper or a gouache crucible. Ensure all the precipitate is collected. Fifth, washing. Wash the precipitate with small amounts of cold distilled water to remove any adhering impurities without dissolving the precipitate. And then, drying or ignition. Dry the precipitate in an oven or ignite it in a furnace depending on the nature of the precipitate. Calcium oxalate precipitate can be ignited to form calcium oxide. 7. Weighing. Cool the dried or ignited precipitate in a desiccator to room temperature to prevent moisture absorption. Weigh the cool precipitate using an analytical balance to obtain an accurate mass. Last but not least, calculation. Calculate the amount of the mineral contained in the original water sample based on the mass of the precipitate and the stoichiometry of the reaction.
Without further ado, let's look at the example of results by applying the gravimetric method in calculation. So, in this case, we have to find the percentage of mass calcium in water sample. So first thing first, we have to construct a balanced chemical equation after the calcium ion is added with the ammonium oxalate, forming calcium oxalate as the precipitation in this case. And then the second is we have to find the molar mass of calcium oxalate by finding each atom molar mass in the periodic table, and we obtain 128.10 gram per mole. So, to calculate the mole of calcium oxalate, we have to divide the mass of calcium oxalate with its molar mass, so we obtain 0.024 mole as our answer. So, the further steps are to find the mole of calcium ion. So we have concluded that 1 mole of calcium oxalate is equal to 1 mole of calcium ions as we construct the balanced chemical equation before, so the answer remains unchanged, which is 0.024 mole. Last but not least, to find the mass of calcium ion in the sample, we have to find the molar mass of the calcium, and then we have to multiply it with the mole we obtained before. So the answer is 0.96 gram. Lastly, the percentage of mass calcium ions in water sample. So we have to use this formula where we have to divide the mass of calcium ions with the mass of water sample and multiply it with the 100%. So we obtain 22.97% of calcium ions in water sample. So we can conclude that in 4.18 gram of water samples contains 22.97% of calcium ions.
So as for the conclusion, gravimetric analysis provides a valid approach for determining the mineral content of drinking water. The findings highlight the importance of regular monitoring of drinking water to ensure compliance with health standards and to prevent potential health risks associated with mineral imbalance. The mineral content of drinking water can be measured by carefully weighing a sample before and after drying. The data obtained can aid in the assessment of water treatment processes and help in maintaining the quality of water supplies. While gravimetric analysis takes time and needs close attention to detail, it produces reliable and precise results that are critical for many applications. Future studies could explore its application in different water sources and further refine the technique for enhanced sensitivity and specificity in detecting trace minerals. So I think that is all from us. Thank you!
Thank you for watching.
Don't forget to
Like and share.
And let us know your thoughts by commenting down below.